This is what would be considered part 3 of this ongoing development of an uncensorable encrypted media sharing specification as well as a prototype implementation. A lot of people have been following this, and I've got a pretty good update with some usable code. And in particular, there is a new command line application which can be found on GitHub, which I'm going to demonstrate in this video. But before I get to that, I want to walk through a new specification and some of the documentation around it, and as well as discuss some of the current events happening, which is a big motivation for why this encrypted uncensorable media sharing protocol is so necessary. So I just took a look at Twitter a couple minutes ago, and it's May 30th, and here is a video of protesters storming the White House. And here is a cop car on fire with riots in Los Angeles, and there were just a police precinct was just set on fire, rioting over racially motivated deaths, and police just killing American citizens and getting away with it. Here's another protest in Miami. So things are really quickly unfolding, and in a previous video I had discussed that one of the reasons why I wanted to build an end-to-end encrypted messaging system is because I anticipated riots, I anticipated protests, because what's happening now is very similar to what was happening in 2009 when we went into recession mode and people were angry. And the system needs change, and in order for that system to change, the citizenry needs to coordinate, and in order to coordinate, they need private, uncensorable communications. And take a look at these people getting the crap kicked out of them by these riot police. I'm never going to do that. I'm going to produce this kind of software to empower those kinds of people to be more effective than to just be a punching bag for militarized police forces. We've got to get smarter, and I don't believe that protesting in the streets is very effective. So let's talk about this encrypted messaging and media transmission. So just to cut to the chase, one of the demos I'm going to show today is how this command line app can be used to send any file of any size to anyone in a way that is very, very difficult to censor, and it's end-to-end encrypted. And so what are some use cases that this would be useful for? Dark web sale negotiations. So, the coronavirus is raging. I've been regularly checking the dark web for hydroxychloroquine. I've read the studies that when hydroxychloroquine combined with zinc has been very effective as a prophylactic. You can make up your own mind. You don't have to believe in what I'm saying about that, but just understand that there are situations where drug deals are both moral and necessary and desirable for the betterment of society. And even though all those things, even though it may be illegal. So I believe that there is a big difference between morality and legality, and that often what is legal is not moral. Just like owning slaves, not moral, but was legal. Outlawing certain drugs, pretty much any drug, I think there's the legal side of things, and I think that's immoral. So I want to empower people to improve the user experience on the dark web for negotiating sales, and an end-to-end encrypted communications channel is very important for that. Also, whistleblowing and leaking. This particular method that I'm going to show, it would be really effective for whistleblowing and leaking because the content would be very hard to stop. It's end-to-end encrypted, so you could get it leaked without anybody really knowing what it is. So this method would be really good for that. I also expect to see a lot of that going forward. And also coordinating protests. We just saw all these protests. If people want to organize and they want to make sure that they're doing it in a safe uncensorable, private way, this is a system that would allow that. So these are going to be some very salient use cases, I think, coming up in the next year or two. And also I want to say that what I'm going to show here is just a rough prototype, but it's in a point. The code's open source. I'm trying to lower the technical barrier, but it's at a point where cypherpunks and crypto-anarchists like myself can take this code and start putting it to work to actually help people coordinate and help people engage in economic activity. So before I jump into the demo, I've actually been working on, let me show you where the code is, and let me show you the specification, because it's the specification really that matters for the long term. Here is, it's on GitHub, and it's under the Permissionless Software Foundation organization, and I've created a new application called encrypt-message. This is also on NPM, though I don't really recommend it. You use it as a typical NPM package at this point. But under Chris Troutner, encrypt. Well, it's in there somewhere. I'm probably... there we go. EncryptMessage. So it's there in NPM. But really what I wanted to show is this code. If you scroll down, there's a README where you can read kind of what this is. There's a link to this new documentation I'm going to show you here in a minute. There's instructions here for installing your own development environment. It uses Node.js. And then here's like just a very quick overview on how to use it, the commands you'd want to run, and the order I'm going to run them in. And this is what I'm going to demo in this video today. But let's check out the documentation, which you can click on that link, or you can just go into the docs folder. And again, in this folder, there's a README here of documentation, and here's a link to the media sharing protocol specification, which is what I really want to go over before the demo. But I also include some links to the historical media around this subject, the podcast I did with CoinSpice, and the videos I've uploaded to YouTube. I'll upload this third video, and should these videos ever get censored on YouTube, I will add links on this document to IPFS and library.io where the videos can be accessed. So let me show you this media sharing protocol specification. This is really ultimately what I want. The application I'm going to show is new and cool and maybe a little clunky because it's a prototype, but it's the specification that's really important. I'd love feedback on the specification. This is what I have put together is just a prototype, and what the specification allows is uncensorable media. So any type of file of any size can be distributed in a way that is uncensorable and inexpensive, and to anyone with end-to-end encryption. And so this media sharing protocol, this document is the specification for that protocol, and sort of how I plan to roll it out in the future. So I start with some acknowledgements to James Kramer and his Bitcoin file specification, which is a way for putting files on-chain versus off-chain, off the blockchain, as well as the Memo Protocol that this is also based on top of and runs the site memo.cache. But without going into too much detail, the Bitcoin Files Protocol now allows files up to 10 kilobytes to be stored directly on-chain, and as I discussed in the previous video, the big advantage of this is content guarantees. Is if it's on-chain, you can be guaranteed that you can get the content. Whereas if it's on IPFS, it's still highly likely you'll be able to get the content, but it's not guaranteed. And there are use cases in which one is usually better than the other. But in general, you want to keep the content off the chain. It's cheaper, it's more efficient that way. And so here is the protocol, roughly. is it generates a Memo Protocol. Here we go. Here's an example on the Block Explorer. So this is an actual Bitcoin Cash transaction that I generated earlier, and this Bitcoin transaction uses the Memo Protocol. So that is signaled with this 6002, and the Block Explorer is smart enough to see that and recognize that it's a Memo Protocol, and so it's going to decode this other part of the string into its clear text, which is what you can see right here. And so that clear text message is the protocol that's documented in this specification here, and it's got essentially 4 sections. The first is just the letters MSG to signal that this is a message, and then it's going to call out the medium, which could be right now IPFS or Bitcoin File Protocol, and then it's going to have a pointer to the content. So in the case of IPFS, this is an IPFS hash, so this is for off-chain, and then if Bitcoin Files Protocol is used, then it will have a pointer to that content, which is on-chain. And then finally, anything left in the operatorn that can fit in there can be the subject, sort of like the subject in an email. So here's an example of the subject. And then there is the signaling portion, which is just a just output to the address who is supposed to be the receiver of the content. And this can be done with or without encryption. And so this part discusses the encryption, and the one caveat that the thing that makes this so much easier than email encryption is that in email, a person has to give you their public key, and that's a huge source of friction, is getting the public key from whoever you want to send an encrypted email to. Blockchain makes that friction go away because you can just pull any person's public key off of the blockchain. You don't need them to give it to you. However, there is one caveat in that address that you want to send to, it has to have made at least one transaction in order for its public key to be on the blockchain. And so that's just sort of an important little caveat to keep in mind. But in general, this approach to the encryption is much easier and lower friction than email. And so that's one big advantage of this protocol. And then down at the bottom, I have a link to the original DIA diagram, as well as an image version of this diagram that I discussed in the last video. And this is just the workflow that I covered in that last video. Let me cover it again really quick. The only part of the web that's used here is this one block where, so Alice wants to send an encrypted message to Bob, so she needs to get his Bitcoin Cash address. And so a web browser using memo.cache website would be a good way to do that, and I showed that in the last video, and that's really the only thing that the web would be used for, and it's optional. There are many other ways to get someone else's Bitcoin Cash address, including they could just give it to you. And so this doesn't actually rely on the web at all, this protocol. It just uses the Bitcoin Cash and optionally the IPFS networks. So Alice gets Bob's Bitcoin Cash address. He's made a transaction, so she's able to retrieve the public key from the blockchain. This is what the software I'm going to demo will do. She encrypts the message, uploads it to IPFS. Then this message could be a file, like a music file or a video file. And then Alice issues a transaction on the Bitcoin Cash blockchain to signal to Bob that he has this message. And then Bob's wallet will scan the blockchain for the signal, find it, be able to locate the data on IPFS with that signal, download it, and then finally decrypt it. And so that's the general workflow in this specification. Okay, so now that I have given an overview of the specification, let me dive in and give a quick demo of the command line prototype. And one of the things I want to point out here is that this will work with the free tier at fullstack.cash. If you try this and you end up getting errors about rate limits and that you need to increase your rate limits at fullstack.cash, this is still possible to use without paying for a subscription. usable with the anonymous, but then if you just create a free account, you go from like 3 to 10, and this program is mostly usable at the free. It's pretty much usable at the free tier. It's pretty much usable at the anonymous tier as well. So let me show that real quick. Okay, yeah, and then I'll talk about future work. Okay, demo time. So I've already. Let me go back to the README. Okay, I've already followed these instructions. I've cloned the repo, installed the dependencies, and I can issue commands with this bin run, and then, like for instance, help will list all the commands, and you can do help list like for a particular command, like the list wallet command, and it'll give you detailed help for that command. We're going to go through these commands. This is the general workflow that I showed in that diagram, where you would create a wallet. Actually, I'm just going to, so if I list wallets. So I've already got a wallet named Alice and a wallet named Bob, and that's what I'm going to use for this demo. But just to show these first two commands, I've already prepared them. Just to show these first couple commands, I'll create a temporary wallet. Run temp, create wallet, and for so if I first of all, for any command, you can do help and then the command to get detailed information. So I'm going to go create wallet, use the -n flag. I'm going to call it temp for temporary. It's not a test net. I'm going to use mainnet, so I'm going to leave the -t flag out. And so there's that. If I can look at the file, it's in the wallets directory. And so right now this is the basic information. The mnemonic here, this is like the private 12 words that unlocks the private key. It's using the 245 derivation, which is for SLP tokens. So this is based on the SLP CLI wallet. So it's an HD wallet, and it can work with SLP tokens. I can get an address. So I've got this QR code, so I could fund this wallet by sending Bitcoin Cash to this address. The important commands here is the set key and get key commands. So I'm going to set a key pair. Let's do the help on that. So just the one command, just like get address, and I'm going to set a key pair. And this is the key pair that I'm going to use for encryption. If this is the address I would give out to people if I wanted them to send me an encrypted message. So if you go to memo.cache, you can see that every person, like I don't know who this person is, but if I go to his profile, every person on here has a Bitcoin Cash address associated with their profile. And so this is the same idea. It's a public there's an address, and there's a private key and a public key associated with that address. And so this is how Alice and Bob are going to. This is equivalent now of basically an email address. And so that's the set key, and so there's only one at a time, and that effectively becomes your identity. And if you need to see what that was, you can use the get key command, and that'll just remind you of what you had set before. So that set key command is pretty important. So I've already run these two commands on my Alice and Bob wallets, and you can see they have a balance. I've already funded them with some Bitcoin Cash by sending them to their public address, or their address. And so now let me show the workflow for actually sending a file. So let's say I have an image. What do I have here? I've got that test PNG. So this test PNG is just a screenshot right here. I'm going to open this up. So that's all it is. It's just a screenshot that I took. But let's say it's some important thing like a treasure map or like the location and information for like an organized protest. And I want to send this out to people, and I have so I'm Alice, and I want to send this to Bob securely. And so what I'm going to do is first I'm going to package the file, and what that does is it's going to create a zip file that contains a JSON file, which is like any messages and metadata, and then the actual file itself. And we're going to do this, and then we'll encrypt the zip file and upload it to IPFS and signal to Bob that he has a message. And then as Bob, we'll run this check messages to see if there's any new messages, and then we'll download and decrypt the new message with this encrypt-message command. So if I go bin run help package file, it takes these two arguments. So I'm running this as Alice. So Alice's wallet is the one paying for it. That's what the -n is. Actually, it's sorry. There's no payment. There's no -n in this one. It's just the F. And so run package file. The file we want to package is this test.png file, which is in the directory where we're working. And -m, so we're going to be this is going to be an encrypted message. Like, Bob, here are your instructions for the protest. Let me know if you have any questions. Alice. And notice I wrapped him in double quotes here. That way the program treats the whole sentence as one string. Okay, so it zipped successfully, and it placed it in this packaged files directory. And so let's take a look at that file. If we open it up, we can see it's a zip file. If we open it up, there's two files. There's our image file that we wanted to send, and then there's this JSON file that's been given a random name. And there's the message that we typed. Now, this isn't incredibly useful, this message here, but what I want to point out here is that this is a JSON file. So this JSON file can contain any sort of metadata that you wanna put in there. And both of these things, the whole zip file is going to get encrypted, and so anything you put in this zip file is all going to go along for the ride. And it's not encrypted yet, so we could like add things to this zip file if we wanted. Okay, so now that the file's been packaged, we can encrypt it, upload it to IPFS, and signal to Bob that he has a message waiting for him. So let's do that. Let's go back to this command, encrypt send. So let's look at the help for that. Bin run help encrypt send. So this has several arguments. We are going to need to pay a hosting fee, which is currently 1 penny. And if you have your own, if you're super technical, you don't have to use fullstack.cache's infrastructure. You can set up your own file hosting thing, and that way this is totally free, other than the Bitcoin Cash transaction fees. But you could actually make the file hosting free, and I'll probably do a future video to walk people through how to set up their own IPFS hosting service, like I'm running at fullstack.cache. So anyways, we're going to pay for this using Alice's wallet. We're effectively Alice right now. The file that we're going to use is that zip file in the pack. This command right now expects the files to be in this packaged files directory. So it's test.zip. That's what we're going to be encrypting and sending. Oh, you know what? And before we do this, we need to get Bob's public address, which we can use this command for. But again, if we didn't have this information, this is what we would get off of memo.cache or member.cache or We just need to know the Bitcoin Cash address that people are expecting to receive messages at. So that's Bob's public address there. So we're going to go bin run encrypt send Alice. We're going to send it to Bob's address. The file is test.zip, and we're going to do a subject. Now this is not going to be encrypted. This is basically akin to an email subject line, and so you don't have to put anything if you don't want to, but I'm just going to say Bob's instructions, and so that's what I'm going to put as the subject line. So it just went out, it found Bob's public key. We can see it matches this one, but normally you wouldn't know what that is, so we'd have to go out and get it from the blockchain. It's negotiated with the fullstack.cache IPFS server. And again, there's lots of services that uses fullstack.cache by default, but there's dozens of pinning services out there that could be used. And you don't even need to use a service. You can run your own IPFS node. And this might take a minute. In fact, it might take 2 minutes. So I'm just going to pause it here, and I'll come back once I get the confirmation that the file has been uploaded. Okay, there we go. A couple minutes, and we got confirmation that the message has been uploaded to IPFS. So it's there for Bob to retrieve. We paid for it with this transaction ID, and then we signaled to Bob's wallet with this transaction ID. Let's just look at that on the Bitcoin Cash Block Explorer. And if we look at the specifications, we can see how this transaction lines up with the specification. So here's the format that the protocol takes. And so here we can see, yep, there's an op return. It successfully detected the Memo Protocol and decoded it. It's got this MSG starter. We signaled that we're using IPFS. There's the IPFS hash, and here's that subject. So it all matches up with this format: message, medium, pointer, subject. And then we can see here that the first output is the change of Alice's wallet, sending the change back to herself. This is the op return output that's decoded right here. And then this last output is a dust output of 546 Bitcoin Cash, and that is to Bob's wallet to signal him, his wallet, that he has a message waiting for him. So okay, so Alice's part is done here, and we are currently sitting right here. Alice issued the transaction to signal to Bob that he has a message. So now we're going to switch hats here. We're no longer Alice, we're going to be Bob. And we're going to run these commands. So now we're Bob, and we're going to run bin run help check messages. And so we can see it's got 2 arguments. And actually this one's optional, so we really just need the name. So we're Bob, we're going to check our wallet, bin run, check messages, Bob. And it's going to walk Bob's transaction history and look for transactions that meet this media specification. There's the last message right there on top. These are previous messages that Alice has sent Bob. And so here's the last one. And so right now, this decrypt-message command that I'm about to run, it only does the latest message. So if someone sent you 2 messages, you kind of have to hack it to get at that second message. So again, this is a prototype. It's really just a proof of concept. So that last command that Bob would run is if he was like, oh, I've got a new message. He'd run this EncryptMessages app, bin run help decrypt messages. And again, this only takes 1 argument, which is the name of the wallet, which is Bob's wallet. Bin run decrypt messages and Bob. All right, and there we get the message that it was downloaded successfully. So if we go back to this packaged files directory, you can see we've got a new zip file with a randomly generated name. And if we open it up, we have the decrypted contents of the original zip file that we started with. So he's got the image, and he's got the JSON data. So yay, Bob has his secure message that was sent peer-to-peer, and nearly uncensorably. I mean, theoretically, someone could censor the IPFS content, and also to repeat what I said in the last video, this content that gets these zip files that get uploaded to IPFS, if you use this app and use the fullstack.cache IPFS hosting, it will be hosted by default for 1 month, and then it will be automatically deleted. And I really like that feature for this type of use case, that things are encrypted by default, deleted by default after a month. And so it gets back to these use cases. I think that's an ideal default values for these types of use cases. And again, just want to reemphasize that this works with the infrastructure at fullstack.cache. You're not under any obligation to use it. All of this software is open source, and anybody, if they have the knowledge and the time, they can run their own infrastructure. They could even, I welcome people to set up their own infrastructure and compete with fullstack.cache. Okay, so looking forward, this is part 3, so there's probably going to be a part 4. I don't know when I'm going to get to this, but the next obvious step forward would be to do a graphical user interface so that this isn't just limited to super technical people. It'd be great just to have a very simple, clean, easy to use graphical user interface. And so I will be working on that. Fullstack.cache is in the process of developing a web wallet, and so this would be just an add-on for that web wallet. But what I'm really interested to know is what the community is going to do with it. What are you going to do with it? This is open source code. I've showed you how to get to it. If you've gotten this far, you're probably a developer, and if you reach out to me, I will give you a free month of access at fullstack.cache. And in fact, the way to get there is to go to fullstack.cache and go to this free access page. And just send me a message. Let me know what, your name and email address that you're going to sign up with, and just say hi and say, hey, you saw this video, and I'll credit your account for $30, which is a month of access to the fullstack.cache infrastructure. And because I really want to see what other people are going to do with it. I think that looking back at history, the Occupy Wall Street movement was a new and kind of beautiful thing, and there were other protests that were also new in that they used social media to organize. And I think that it's a different ball game. The forces involved are the same, but the governments are much better at censoring the internet, and particularly large platforms like Twitter and Facebook and YouTube. And so if people, I get that people are angry, obviously that's why they're protesting, but if people want to actually affect change and change the way the system works, rather than just expressing their raw anger, they need to be smart about it, and they're going to need cypherpunks and crypto-anarchists like me and like people in the Bitcoin Cash community to help them coordinate, to help them use these new tools. The revolution will not be televised, as the saying goes. The government that they're protesting against controls the major media outlets, so why would those major media outlets do anything other than help the government with their propaganda to maintain the status quo? So we've got to use new tools. We've got to be smarter. We've got to stop being punching bags for policemen. And we need to organize. And we need to communicate securely and exercise our rights to free speech and privacy.